Hi everybody, Mr. Lee here. In this video, we are going to go over the accelerated motion. Let's begin. So before we begin, let's go over the definition of acceleration. So hopefully by now, you should know what the definition for acceleration is, but just in case you missed out on that, here we go. It is when a object either speeds up or slows down. Now in class, you might have seen me write it like this: SP upwards or SL downwards. Now, of course, that always helps us out, but a lot of times in physics, we are using formulas. So let's also put that down. Acceleration is the change in velocity over the change in time. Now, as a reminder, that delta or that triangle means change. So if we have a change in velocity, this can only mean two things. We're either speeding up or we are slowing down. Now, later on, we will add to this definition, but for now, this actually works out pretty well for us. Cool. So let's come up with the motion map. Now, hopefully by now you have already come across this problem on the motion map, and we've discussed it. But just in case we didn't, here we go. So I'm going to do the motion map the way that we see it on the worksheet, but I want to show you the way that I like to draw it. Yeah, so we should have something like this. Okay. So before we start, let's have a verbal down. A good verbal is the key to solving any and all of these problems. Write this down in your notes. We can say an object moving to the right speeds up. All right, ta-da, just like that. Let's highlight that. Let's increase the font size to 20. There we go. All right, so we have an object that's moving to the right and it's speeding up. So I'm going to draw the velocity vector right there. Okay, boom. My velocity vectors are, in fact, getting bigger because we are speeding up. Cool. Now for the acceleration, I actually like to use a different colored ink for this one. The acceleration shows us how much we are speeding up / slowing down. So if we are speeding up to the right or in the positive direction, our acceleration must show that. Okay, we are speeding up to the right, like so. We're speeding up to the right, like so. We're speeding up to the right, like so. Now I tried to make my acceleration vectors relatively the same size, and this is important because, let's see, same size, because we have uniform acceleration, and uniform just simply means that it is not changing, it is constant. Uniform acceleration. Okay, and so that shows us a object that is speeding up to the right. All right, now let me show you how I like to draw it. So this way is fine. The only way, or the only thing that I like to really change is I just like to have my acceleration above, like so. Okay, it's just a personal preference. Right, and I just like to label that acceleration. You don't have to do it that way, whatever way works for you, but just know that no matter what method you choose, you have to label your vectors. So my velocity vector is the black ink, and my acceleration vector is going to be the red ink. All right, cool. Now let's do a couple of different ones that you might come across. So let's do, let's write a couple. So we can say an object speeds up to the left. All right, so we'll do that one. So this will be scenario 1. Oops. And let's do 2. An object moving to the right slows down. Okay, and then we can say an object moving to the left slows down. All right, so a lot of different combinations that we can do. Let's increase the size font for all of this. Yeah, 20. Whoa, that's big. There we go. All right, so an object speeds up to the left. Let's do this. Let's have a, my position line. Let's start over here. Let's say x is equal to 0 here. We have an object that is speeding up to the left. Okay. I can also say that's the negative direction. So this is my velocity arrows. So if my object is speeding up to the left, that means my acceleration vectors, okay, I'm going to have my acceleration down here. It's also going to be in the same direction. Now remember, acceleration shows us the speeding up or the slowing down. So if we are moving to the left and we're speeding up to the left, okay, that little statement right there, speeding up. So wherever you see speeding up, or the word speeding up, or if you're verbalizing speeding up, to the left, right? So having this entire verbal helps you out with the motion map. So if we're speeding up to the left, that means our acceleration must be going to the left. All right, number 2, an object moving to the right slows down. Okay, so if we have here, position, let's see, we have velocity here. So we have, all right, so we have an object that is moving to the right. Okay, and we slow down, right? In fact, we come to rest there. So if we are moving to the right, but we're slowing down, that must mean that our acceleration, okay, our acceleration is to the left. Because if we were speeding up, right, if we were speeding up, that means that our acceleration would be to the right. Okay, now, if you're wondering, Mr. Lee, why did you do the acceleration right there? Simply put, because we are under uniform acceleration, meaning our acceleration is constant. So I want to show us that our acceleration is constant. Now, I did offset my dots just a little bit. You don't have to do it like that. You could actually have it line up, and it's like a personal preference for you. But I just did it this way. You can do it the other way if you would like. All right, so we have acceleration shown a little bit more accurately in both regards. Cool. So the third one is a object moves to the left and it slows down. All right, so hopefully by now you're getting the whole gist of this. You could probably do this on your own without me, but you know what? That's why I'm here, to help you out. So our velocity vector, we're moving to the left, but we are in fact slowing down. All right, so because we're slowing down, my velocity vectors are going to shrink. All right. Now, if we are moving to the left, but we are accelerating, okay, we're accelerating by slowing down, that must mean that our acceleration must be to the right. It has to be the opposite. Like so. Look at that. That's pretty good. Okay, once again, at the end, I will put the acceleration down just to show that we are under a uniform acceleration. Okay, so let's come up with a couple of rules. For speeding up and slowing down. Rules. All right, so speed up. We are speeding up if we have a, let's call this the velocity column, and let's call this the acceleration column. We are speeding up if we have a positive velocity, okay, because we're moving to the right or up, and our acceleration is positive, okay, and we're speeding up to the right, or we're speeding up upwards. We can be moving to the left, okay, and we could also be speeding up to the left, or we could be moving downwards and we could be speeding up downwards. All right, so notice here, signs are same. Okay, now this next column, I'm going to put a little star next to this one because this one's important. If our velocity is 0, but we still have a positive or a negative acceleration, we are still speeding up. So what that tells us is that even though we are not moving, we will start to move. Okay? All right, so the signs are the same, or if you have a velocity of 0 and we are accelerating, we are speeding up. Okay, so with that, the rules for slowing down, you can probably figure this one out, but just in case, let's do this. If we are moving to the right, but we are slowing down, that must mean that our acceleration is negative. Okay? Or we could be moving to the left or in the negative direction, but we are slowing down, therefore our acceleration must be positive. Notice here, signs are opposite. All right, pitfalls. A lot of the times, okay, so this is a big warning. I'm going to do this in red. Warning, warning, warning. Students believe positive acceleration means speed up. Okay, that is not the case. Students also believe that negative acceleration means slow down, but that's not the case. All right, so put that down in your notebook, make sure you have it, and yeah, that's the official end of the unit. I'll see you next time. Bye-bye.